Since we started thinking about a van build about a year ago, we've both been part of several different van build and van life forums and Facebook groups, and it has become abundantly clear that the thing that people struggle the most with a van build is the electrical side of things. So we thought we would start this video where at the end we're going to talk about our electrical system with a beginning that is just the basics of an off-grid electrical system, because we think there might be a need for that.
And we've done this how many times now? This is our fourth time.
This is our fourth time building an electrical system for an off-grid vehicle. 2 boats, 2 vans. So we think that in Andy, engineering background.
ABYC certified.
And he's ABYC certified now, which is pretty cool. A comprehensive off-grid electrical system actually consists of 3 separate systems. You have your storage, you have your input, and you have your output. And we're gonna break down the basics into each of these 3 systems. We're gonna start with talking about storage. In most cases, storage in a van is going to be a house battery bank of some kind. Let's talk about sizing a house bank for your van or boat.
Okay. You're gonna wanna figure out how much power you need, which is kind of a daunting task, but it's not that hard to figure out. Simplest way, you can flip over some of your devices. They will tell you how many watts they use. And then you can do a little bit of math to figure out how many amp hours that is, depending on what voltage you're going to run. Another nice thing is to use like a kilowatt meter that you plug into the wall. And you can, for example, plug your laptop into that and then work for a couple hours and see how much energy it actually uses, which is a little more accurate than just flipping your device over.
We actually did that when we were still living in our house, when we were trying to size our battery bank for our first boat. And it was extremely helpful because we had things that used a lot less power than we thought.
Yes.
And we had a few things that used a lot more.
My laptop.
Andy's work laptop uses a lot more than we had anticipated. So we highly recommend that option. Just make like a spreadsheet or a list and just figure out like your laptops, your cell phones when they're charging.
Cooking appliances like an Instapot or induction cooktop if you're going to decide to go that way. You just kind of want to add all those things up, and you also don't want to forget about things like lights in the van. Most are LED these days, and they use only an amp or 2, but just don't forget about those. And then another thing is like a ventilation fan. Don't forget about those as well. And remember, you're going to run those for about 12 hours a day. A lot of these items use a lot of electricity for just a little amount of time, but other ones use a little bit of electricity all day.
A long time. Once you have that number, then you have to make a decision about what kind of battery you are going to purchase. All right, let's talk about voltage first. So what are your 2 voltage options? Well, you really have 3, but we're not going to do 48 on this video.
Not gonna do 48. So right now, your traditional voltage options are 12 volt and 24 volt. The advantage of 12 volt is that a lot of your items run like ceiling fans and LED lights and refrigerators and stuff like that all run natively at that voltage. 24 volts is nice if you have like a high powered system. So if you're going to have lots of electric cooking, electric ovens and things like that, and big inverters, running 24 volts is nice because you get to use a lot smaller wire, and wire is pretty expensive and heavy.
But 24 volt batteries are typically more expensive as well.
More expensive as well.
It's a trade-off.
And you will need some extra equipment to convert the to make that work with the 12 volt items that you will need to use. Typically, your huge high power systems tend to be 24 volt and smaller systems tend to be 12.
Which is why in a van or a small boat, we have gone with 12 volt systems in all 4 options.
Yes, we've done 12 volt and everything.
So once you decide if you want to go with 12 volt or 24, then you need to decide what type of batteries that you would like to install. There are a few different options.
There are 2 main type of batteries used in vans. First is lead-based, and then the other type is lithium. Lead-based batteries are flooded lead acid, AGM, and gel cell, and there's also some sealed lead acid batteries as well. In vans, you typically would want to use the AGM, the gel, or the sealed lead acid. Typical flooded cells are really old technology, and you have to add water, and they vent hydrogen gas when you're charging them. And it's just a lot of stuff to deal with safely. I would limit yourself to either AGM's gel or the sealed lead acid, sometimes called valve-regulated lead acid batteries. And then on the other hand, you have lithium batteries. We're only going to talk about lithium iron phosphate because those are typically the only chemistry used for off-grid storage and things like that. There are some others used in electric cars and cell phone batteries, but they just really aren't used in this application because of some safety concerns, and you really don't need the extra expense of those type of chemistries for what we're doing. There are pros and cons of both. The pros for the lead acid based batteries, the AGMs, the gels, the valve regulated, is they are inexpensive.
A lot less expensive.
And that's it. The pros for lithium are pretty much the cons for lead. Lithium batteries are about 1/3 the weight per amp hour of lead acid batteries. And then they are also about between 1/2 and 1/4 of the size per usable amp hour. Another pro for the lithium batteries is that you can cycle them from 100% to around almost down to 0% without damaging them. In lead acid batteries, you really don't want to start sending them below 60 to 50% because at that point, the deeper you discharge them, the less their life. A lead acid battery may have 300 cycles if you discharge it to 50%, and it may go to 900 cycles if you only do 75%. So those are the kind of ranges you're looking at with lead acid batteries, but with lithium batteries, you can cycle. They don't have that type of memory, so you can cycle them from 100% to 0% 5,000 times before you start seeing some degradation.
Yeah, and when we talk about usable amp hours in a battery system, we're talking about basically in a 300 amp hour system. If you're using lithium, then you're getting 300 amp hours basically of usable electricity. But if you're talking about an AGM, that 300 amp hours of AGM, you're really looking at 150 to 125 usable amp hours. So that's really important to note when you're thinking through your bank size versus your usage.
In the last few years since we've started a couple of our builds, the price of lithium batteries has come down drastically, and there is a lot more manufacturers around. So if you do the math, it's almost cheaper nowadays just to do the lithium batteries, but there is a little bit more care required for lithium batteries, and we'll talk about that in a little bit. First van build, we went with just an AGM battery that we picked up at Costco. This was back in 2017.
I think.
Lithium batteries were pretty expensive at the time, and this was just a budget build, a weekender, so we went with an AGM because all we were running was a fridge and a fan and a couple cell phone chargers.
Second build, Ecola, is when we switched to lithium.
Yep.
And we did 300 amp hours of Battleborn batteries in that. And we have used those straight through for the last, since 2020 to 2024 in both boats and have loved them. They've done us very well.
No problems.
We have outgrown the 300 amp hours though.
Yes.
We learned a lot about ourselves over the course of the last 4.5 years of off-grid living. And one of them is that we use significantly less water than the average person, but significantly more power. So we had been talking about upgrading our battery system in Acadia, our boat, and we had actually already purchased those batteries before we started our van build. And when we started thinking about it, we're never going to be in both the van and the boat at the same time. So we've decided that we're going to share our battery system between the van and the boat. And we now have 900 amp hours of epic batteries. And they are great.
Great.
We've been using them for about the last 6 months. We've only had one situation where we've started to get low, and That was really our own fault.
Yes.
So we'll talk a lot more about what we're using on an output side of things in this build, and you'll see why 900 was a bigger deal for us. But I will say that one of the biggest reasons we needed more power on the boat when we started talking about increasing our storage was that we now have Starlink, and Starlink is a power guzzler. So that's kind of where we really started to feel like our 300 amp hours wasn't quite enough. And I know we have a lot of friends in the cruising community that have also had to upgrade their battery banks since getting Starlink. So just something to keep in mind if that is something you're planning to do. It is extremely power hungry and will cost you a lot on the power side. That's pretty much the basics of storage. Well, let's talk about the fun part next, which is how do you use the power that you are storing in your batteries? So the output system. There are basically two subsystems within output. There is your direct current or DC system and your AC or alternating current system. And we're going to talk about those kind of separately because they really are two separate systems.
Yes.
Let's start with the easy one.
The easy
DC.
one, DC. So this is your like direct current. This is going to be the stuff that ties directly to your battery at its native voltage. So like most cases, it's going to be 12 volt. This is going to be things like your fans, your lights, probably your phone chargers and things like that. What else do we have running on DC? In our case, the fridge, right?
The fridge. Our AC runs off of DC.
Yes. And that's about it, right?
Water pumps.
Yes. Okay.
So DC is easier to set up. Basically what happens is you run a wire from your batteries output into a fuse box, and then from the fuse box you run wire to all of the pieces that you're going to be operating. So we have a fuse for our fans, we have a fuse for our lights, we have a fuse for the fridge, and basically it runs into the fuse panel from the battery, and then that fuse block is where everything runs out into the system itself. So you can probably see our roof vent fan, you can see our air conditioner and our lights. All of those have DC 12 volt wiring going from the fuse through the walls and up to where they are. But if you want to be able to run your household appliances, your laptop chargers, anything that runs off of 110 or 120, anything that has like a normal household plug, you're going to need an AC system. So how do we take the DC power that comes out of the batteries and make it AC so that we can plug in our household stuff?
So to convert the 12 volt to 120 volt household power, you use an inverter, and that steps up the voltage and applies the alternating a current to it using a series of transformers and MOSFETs to do it. I don't understand exactly, but it's a magic box, okay? So typically
you don't need to know the actual electrical engineering parts of this to make it work, right? Like we're talking about,
Okay.
there are certain things about this that we just say are magic.
Magic. Run on magic smoke. So let the smoke out. It doesn't work anymore. Because of the nature of inverters stepping the voltage up, when you're using like a 6 amp device on an inverter, it's going to use close to 60 amps at 12 volt. So you got to be kind of careful about what you use on 120 on your 120 volt system. So like if you plug in a hot plate, you're going to need an inverter big enough to handle that, and also you're going to need batteries big enough to handle that.
The most important piece of the AC system is making sure you're sizing your inverter correctly. So you need to know how many watts, because inverters are measured in watts, not amps. We've been talking about amps as we've been talking about batteries and DC power. But in terms of AC power, you're going to talk a lot more in watts. For us, our 3 largest power draws on our AC system are our oven, our induction cooktop, and our water heater. So we needed to make sure that we could run at least those by themselves, but hopefully one of those plus the draw of like our Starlink or having a laptop or a monitor plugged in. Most of, actually all 3 of those items run about 1400 watts when they're in like startup power. So those, that leaves us with about 600 watts on our 2000 watt inverter. If you are planning to do a fully electric galley, you may want to step that up to 3,000 watts. Or if you have just laptop chargers, you could probably get away with 1,000 watts.
Or 400.
Yeah. But for us, we definitely needed 2,000, and we've had 2,000 in all of our grid setups.
And it's been wonderful.
There are days occasionally when I want a little bit more, but not often. Occasionally when you want to have the induction cooktop and the oven going at the same time. That's the only time I ever want more. So how does the battery get to the inverter and the inverter get out to the parts we actually plug in?
Okay, so the inverter on the 12 volt side or 24 volt, the low voltage side of the inverter, you're going to have two cables, one that connects to the positive of the battery and one that connects to the negative. The negative just connects directly to the inverter, to the battery. Done. The positive side will have a fuse and a shutoff switch somewhere in that wire. The inverter manufacturer will help you with what size wire to use and how big of a fuse. So smaller inverters will have plugs on the side that you literally just plug your stuff in and you're done. Larger inverters will have output terminals. From that output terminal, it will run into a circuit breaker box. In our van, we have two circuits, one for the left side of the van and one for the right side of the van. So basically, out of the inverter to a fuse box and then onto your outlets.
Easy peasy, lemon squeezy.
Yes, and those are wired very similar to how houses are wired, so those are pretty easy to figure out.
Any important things about running wires through the walls of vans?
You need to be careful about having any wires chafing on sharp edges. Vans are made out of sheet metal and the edges are sharp. So where it runs through or past any sharp edges, you want to cover that with something, either a loom or like some split tubing to protect it.
The other important thing to talk about when we talk about wiring for both 12 volt and the 120 system in a van, you want to make sure that you are not using solid wire. You want to make sure you're using stranded wire. When things are like moving all the time, stranded is not going to have the issues that solid would. All right.
Next thing, inputs, my favorite.
So now that we know how we're going to use all of the power that we are storing in our batteries, how do we get the power into the batteries in the first place?
This is the fun part. You're going to need some way to charge those batteries, and there's four common ways to do that. Obviously, for off-grid people, the most common way is solar. You put some solar panels on the roof. It runs through a charge controller that regulates electricity to charge your batteries properly. That's probably one of the simplest, quietest, easiest ways to get electricity, and that's probably where we get 75% of our power.
I'd say about 75%, yeah. And on the boat, it's probably more than that.
More than that.
We are going to do a deeper dive into our solar setup in a separate video because we want to talk about our roof mount and how we have 750 watts of solar on top of this Promaster 157, which is a lot, especially since we have both a fan and an air conditioner up there. So
I got 1,000.
Andy's having regrets. But we'll talk about that in a separate video because I think the roof rack itself is worth talking about because it's pretty clever.
The second way that most people get power is from the engine itself. There's two ways to do that. One is to have a separate alternator. Some vans have a spot for a separate alternator that would connect directly to your batteries in the back and charge it that way. That is a nice option because you get a lot of power, but it's an expensive option and you have to have that bracket to make it work.
Our friends Show and Joe,
yes, our
Jen
friends,
and Elliot, they have a dedicated spot for it, and they put one in, and we're kind of jealous.
Very jealous.
But there's not a great spot here on the Promaster, so we've not gone that route. We've gone the other route, which is.
So if you're not going to use a separate alternator, another option is to use either a battery-to-battery charger or a split charging relay. And what that does is that when your van's running, you're going to have an alternator. In this case, it's 180 amps. It's not using all that power all the time. So you can take a little bit of that power from that alternator and divert it to the batteries. And that's what a battery-to-battery charger. It takes some of the power from the engine and uses that to charge your batteries.
So for every hour we drive, we put 50 amps into our batteries. And it's nice because it means that if on like a 3-hour day, we pretty much will top ourselves up.
Yeah, so we'll add 50 amp hours for every hour we drive.
Yeah.
But unfortunately, if our batteries are completely dead, it will take 16 hours to charge them up.
Which is why we still have other options. What's the next one?
The next option is shore power. So like if you go to a campground or something like that and plug in, you can charge your battery using a battery charger. And that just essentially on one end has a household outlet plug on it. And then the other side connects to your batteries. And that's pretty simple and it's easy, but you got to be at a campground or somewhere to plug in to do it.
Mooch docking, something. We're currently plugged in at your parents' house. Our inverter doubles as our battery charger, so that was kind of a twofer. It's expensive. The inverter's expensive, but we love our Victron inverter.
Mm-hmm.
But it's also the shore power, so that's where our plug comes in and goes to the batteries. The last option, which is our least favorite option for both us and others.
That's a generator. So either a portable or built into your RV, you'll have a generator, and that will essentially make 120 volts, just like you're plugged into a wall, and that will charge your batteries through via a battery charger.
It does require a battery charger the same way shore power does, so it is an extra piece of equipment there.
Yes,
as well.
and you want to make sure, if you're going to do that route, you need to make sure your battery charger is sized appropriately with your generator. Too small a battery charger, your generator is just going to sit there making a lot of noise, bugging people for a lot of times, but if your battery charger is too big, your generator will trip out. So you need to kind of make sure those work together carefully.
I do think it's important that if you're considering a generator as your primary power source, that you know that from an etiquette standpoint when it comes to generators, most folks are going to frown at you if you're using a generator in like a boondocking scenario. It just ruins the peace and quiet. Most people are out in the woods because they want peace and quiet and to be away from people, and they don't want to listen to your generator all day long. And in many campgrounds, if you don't have shore power but you have a generator, many campgrounds have limited generator hours or limited spots where generators are allowed. So it's important to keep in mind that it's not a foolproof option for those reasons. And just please don't be the person out there just running their generator 24/7 in a boondocking spot. We don't have one.
No, we don't have one.
And we've never had a generator in any of our off-grid scenarios, and we haven't needed one yet. We've had one scenario ever
Once.
that we've wanted it.
Yes.
So
what have we talked about? The three things, right? We got your storage, how you're going to use it, and how you're going to charge it, right?
Yeah.
That's pretty much it in a nutshell. You got to put energy in to use it later.
You pretty much have to be putting it in mostly continuously, but
yes,
you're not going to want to run your engine or your solar overnight, which is why you need batteries. So I know that we talked about some of our components as we have been talking about each of these three systems at a basic capacity, but I thought it might be a good idea for us to run through our system separately so that we can just talk about each of the components and why we made some of the choices we made. We'll wrap things up.
Yeah. The heart of our system here is three 300 amp hour epic lithium batteries that we have all hooked together to create a bank of 900 amp hours.
So on the output side of things, we run our DC side of things forward, and there's a couple things that come backwards. We run our lights, our roof vent fan, our just regular fan, our air conditioner, our refrigerator, and a bunch of charging ports for phones, USB power ports in a variety of locations, all run on the DC system.
Yes. That's so we can charge phones and things like that without the inverter being on.
On the AC side, we have a Victron 2000 inverter charger combo, and that is running the 120 side of all of our plugs. That runs forward to 4 household outlet plugs. They're all GFI'd so that if any moisture or water gets involved, it's not a big deal. And those plugs run our oven, our induction cooktop, all of our computers and monitors and all of that stuff for work.
Yeah.
And
Starlink,
and also our water heater. And obviously we have a few things we'll plug in, like chargers and that kind of stuff get plugged into that occasionally. And just anytime you want to plug just any old normal appliance. We carry an Instapot, a immersion blender,
bunch of power tools.
a bunch of power tools.
There's a lot
I think
of stuff.
that's about it.
There's a lot of stuff.
But it's important to think about those things when you're considering not doing an AC side of your electrical system, is that there's a lot of things that you're giving up if you're going to not do that. later on, we'll do some videos on our electric galley and the pros and cons of that versus the propane that we have on the boat. And we'll also be doing a video on our air conditioning unit because, man, oh man, that thing is. So stay tuned for those as well.
Now we can go to my favorite part.
Yes, our input systems.
So on the input side, we got 3. We have our Victron 50 amp battery to battery charger, which connects to the van electrical system itself and charges our batteries at 50 amps. Next up is solar. On the roof, we have 3 250 watt rich solar panels connected to a 50 amp Victron charge controller. Lastly, we can charge the batteries with shore power, and that's through our inverter charger. So when we plug in our shore power cord, our inverter changes mode to battery charger, and it will start charging the batteries instead.
It does both.
It
can invert and charge at the same time.
It's crazy. We could do a whole video on how awesome this inverter is. So we've talked about the 3 things. You got your inputs, you got your storage, your batteries, and then you got your outputs. And somehow you need to figure out what the heck is actually going on with all this stuff. And that's where like a battery monitor comes into play. And what that does is it tells you how much power you're using, how much power you got left in your batteries, and sometimes will tell you how long you have until your batteries are dead. And in our case, because we got Victron for everything else, we got a Victron battery monitor, and it tells us in a percentage on a little display how much power is left, and if we're charging, how much amps are going in, or how many kilowatts are going in, or if we're discharging, how many amps are going out, or how long we have till the batteries are dead. We just got the simple one. I kind of wish if I was gonna do this, that's my only regret with the system. I didn't get like the color Victron touchscreen one because it's really cool.
A lot more expensive though.
Yes, it was like $500 extra.
I don't think that there's much we would change about this system, but this is our 4th build and we have made some changes since we started doing this. And the biggest one that I highly recommend, and probably my biggest tip to take away, is you don't want to cheap out on your electrical system from a component standpoint. So you can make some compromises, like if you want a smaller inverter or things like that to save money, but I wouldn't go with the cheaper option. Victron is the gold standard for a reason, and we will sing their praises from the rooftops. We've gone with alternative options in previous situations, and we would never go back. I think the exception to our kind of Victron rule is that we do have a lovely Balmar battery monitor that we have on the boat that we really like. And that one has been around. We've had it for 5 years and have had no issues with it. So, but the other components that we've previously used, with the exception of a kind of off-market, an off-brand inverter we had on Ecola, I think that Victron is the gold standard for a reason. So, and if you ask our opinion, that's what we're gonna tell you on a particular component, is go with the Victron option. And it just works, and they honor their warranties, and their customer service is good, and I can go on.
Yes.
But yeah, so that's it in a nutshell. As usual, if you want to leave a question in the comments, we will attempt to answer it.
We will answer it.
Andy's feeling very confident. Also in the description of this video is a blog post that will link to all the components we've talked about today, as well as a breakdown of all of the basic information that we also talked about at the beginning of this video. We appreciate you watching, and we'll see you next time.